topic of organic chemistry, haloalkanes and haloarenes. This class, we are going to just touch the important topic. First of all, let's start with the preparation of haloalkane. Preparation of haloalkane. There are the various preparation methods. Very first preparation method that we can prepare the haloalkane alcohols. When we are going to prepare them from the alcohol, it is a very easy. For example, you are having any alcohol, make it react with the halogen acid in the presence of the zinc chloride, provides us the alkene water molecule gets liberated. Here X can be the and the iodine. Another preparation method from the haloalkanes can be what? That we have taken an alcohol, we are taking a NaBr and H2SO4. When you are going to take it, the haloalkane which is going to form, it is a for the bromine, and we are going to form a sodium hydrogen sulfate plus a water molecule will get liberated. Next method can be what? That we are taking a 3 molecules of the alcohol and make it react with the px3. Over here, X can be the chlorine or the bromine. So, what we are going to get? We are going to get the 3 molecules of the alkane plus H3. Now, over here, what is going to happen? That we are having a alcohol, making it react with the PCl5, get a haloalkane plus Cl3 and HCl. Another method can be taking a alcohol, making it react in the presence of the red phosphorus, a halogen molecule. Your halogen can be iodine or the bromine. Get the haloalkane. The last method of preparation from the alcohol can be what? That you have taken alcohol, make it react with the thionyl chloride, that is your SOCl2. So again you get a haloalkane plus sulfur dioxide gas is liberated and hydrochloric acid we get. This particular reaction we say the reaction of primary or the secondary alcohol with a halogen acid require the presence of the catalyst, that is your ZnCl2, the reaction which I have done at the top. Without this particular catalyst we cannot perform this reaction. So this was the few methods of the preparation of haloalkane alcohols. Other preparation methods can be what? Besides alcohol, we can prepare them from the hydrocarbons. Now, when we are going to prepare them from the hydrocarbons, this particular reaction is going to a free radical halogen. Let's look the reaction. CH3, CH2, CH2, in the presence of chlorine and UV light, or in provider. So what we are going to get? Over here we are having the 4 molecules So writing down with the four molecules only, and one molecule of the hydrogen, one atom of the hydrogen is going to replace by the Cl. Now this is what, if we are going to do the naming, it is your normal butyl chloride. Besides it, we also get the, or there will be the also formation of the this. That is your secondary butyl chloride. Okay. Next, if we want to prepare a haloalkane, then we can also prepare these besides the alcohol and hydrocarbons. So let's begin with the alkenes. The very first reaction in the case of alkene is what? Addition of hydrogen halides. Now, when you are going to do the addition of hydrogen halides, what is going to happen? This is our alkene which we have taken. We have taken a hydrogen. Now, what is going to happen over here? We know that your halogen is having a delta negative charge. Because of its negative charge, this hydrogen will get the delta positive charge. Now, when there will be the shifting of the bond will take place, so because of which, what is going to happen on any of the one carbon atom, electron density is going to increase. Now, let's suppose over this carbon atom, your electron density has increased. So, what is going to happen? It will have negative charge. Therefore, this hydrogen will come and attack over here, and this halide is going to come and attack on this carbon atom. So, our product, it will be a bond will get break, double bond, and it will get formed. Over here, X can be the chlorine and iodine. Now, say suppose the alkene which we have taken, this, and a hydrogen halide. Now, this hydrogen is going to atom, and this halogen is going to attack on this carbon atom. So what will be the result over here? Now, sorry for the disturbance due to network issue. Now, this has followed a Markovnikov rule, but addition can be in the another manner also. That is your CH double bond CH2 plus HBr in the presence of benzoyl peroxide. Now, whenever we are taking over here HBr and we are having the presence of this benzoyl peroxide, so what is going to happen? This we are going to attach over here, and this hydrogen is going to over here, means this particular reaction is going to follow a anti-Markovnikov. So what will be your product? RCH2CH2Br. This will be your product. Another reaction can be what? That is your addition of halogens. when we are having a addition of halogens, so alkene we have taken, make it react with the Br2. It takes place in the presence of carbon tetrachloride. So this particular reaction is going to provide a vicinal dihalide. So as we are having a bromide, so we called it as a vicinal dihalide. Vicinal means what? That the halogen atoms has attached to the neighboring carbon atoms. With this, we finish the three preparations of the haloalkanes. The very first is what? From alcohols. The second is from hydrocarbons. The third is from alkenes. Now, the last preparation method for the haloalkanes comes your fourth one. I should write it D. That is your halide exchange. Now, when we are having a halide exchange, this halide exchange reaction comes under a category of the named reactions. So let's look what named reactions are this. In this, first part is your bi-Finkelstein reaction. Now, when we talk about a Finkelstein reaction, we take a carbon chain and make it react with the sodium iodide. Now, basically, in this Finkelstein reaction, if you say I have taken a over here already halogen, means my alkyl halide only I have taken in this reaction, and I'm saying it is a halide exchange reaction. So, what is going to happen? In the presence of the dry acetone, it is iodine is going to come to the carbon chain and your halogen is going to attach with the sodium. Over here, X can be chlorine and bromine. Second reaction in this case is your bi-Schwarz reaction. Now, what does this Schwarz reaction is? Again, we have taken an alkyl halide. In this, we are having a variety of reagents. You can take AgF, you can take Hg2F2, you can take COF2, you can take SbF3. So what is going to happen? Your halogen which was present in the reactant, it will get replaced by the chlorine. Let's look at with an example. Say suppose I have taken a methyl bromide. I make it react with AgAF. So what is going to happen? Methyl fluoride will form and silver bromide is going to form. By this reaction, we finish with our preparation of the haloalkanes. Now, the next important topic in this unit comes with the chemical properties. When we talk about the chemical properties, we are going to cover the three things over here. What are those three things? The first thing is your nucleophilic substitution reactions. Then the second thing is what? Dehydrohalogenation. Dehydrohalogenation. This dehydrogenation is also known as a beta elimination reaction. And the last reaction is the reaction with metal. Now let's start with the nucleophilic substitution reactions. Now, in this case, nucleophilic substitution reaction, what is the meaning of this? When an atom or group of atoms is being replaced by a nucleophile, the reaction is going to called as a nucleophilic substitution reaction. In the case of haloalkanes, the halogen atom is attached to the carbon atom. As the halogen atom is more electronegative than carbon, the bond between the carbon and halogen is polar in character, like I am showing over here. So what is going to happen? Polar means it is going to have the delta positive and it is going to have a delta negative charge. Now this I am taking it as a subtract. Now due to the presence of this partial positive charge on the carbon atom, what is going to happen? The nucleophile is going to attack on the carbon atom. Why? Because it is going to be the electron deficient. Therefore, the displacement of weaker nucleophile is going to take place. That is your halide ion. What is going to happen? It is going to come over here and your halide ion is going to displace. Means it is going to called as a leaving group. Now let's recap once our all nucleophilic substitution reactions. In the case of nucleophilic substitution reactions of the alkyl halides, that is your RX, we can say this we have taken alkyl halide. So what all reactions can be done over here? Let's look at 6 reactions we can have over here. The first condition is it is going to react with KOH aqueous. Over here, it is very necessary to mention the aqueous condition. Then another NaR. In this, Na will be positive and this will be negative. Then KCN. It is alcoholic. Then AgCN, KNO2 plus AgNO2. Now let's look what are going to be the products. In the case of aqueous KOH, you are going to have the alcohol plus a halogen will come. In the case of NaOR, you are going to prepare the ether plus sodium halide is going. KCN के केस में it will be RCN, means you are forming a alkyl cyanide. के केस में alkyl isocyanide plus silver halide. KNO2 के केस में you are going to have the alkyl nitrite plus potassium halide. And then in the case of AgNO2, alkyl nitroalkene plus silver halide is going. So these are under the category of the pure nucleophilic substitution reactions of alkyl halides. Besides this, we are having other more reactions. Let's look them also. Let's look Let's look the products in this case. In this case, we are going to have the esters. Over here, we are going to have the alkane as reduction is taking place. NH3 we are taking amine. NaSH means a thio alcohol is going to form. And in this case, a higher alkyne is going to form. Basically, you can say the chemical properties which we have done under this category, we can use them in the case of the preparation methods or the conversion methods. Second one, second chemical property is your elimination reactions. Now, when we talk about the elimination reaction, so what is about it? When haloalkane with beta hydrogen atom is heated with potassium hydroxide, that should be ethanolic, there is elimination of hydrogen atom from beta carbon atom and a halogen atom from alpha carbon atom takes place. As a result, alkene gets formed. Since beta hydrogen atom is involved in the elimination reaction, therefore it is called as a beta elimination reaction. Let's understand this reaction with the help of one equation. KOH should be alcoholic. Heat is given, alkene is going to form ACl plus a water molecule. Let's understand its mechanism part, how it is going to happen. So what is going to happen? This is my alpha carbon atom and this is my beta carbon atom. When OH has come over here from the alcoholic OH, it has attacked over here. Bond is going to shift over here and this bond is going to shift over here. Because of which, what is going to happen? Your alkene is formed and a water molecule going to liberate, ion is going to come. Now, this is the case when I was having only one beta carbon atom over here. But we can have the two beta carbon atoms also. So in that case, what is going to happen? CH3, CH, CH, CH2, H, Br, H. Now in this case, if you look, this is my alpha carbon atom. This is my beta carbon atom. This is my beta carbon atom. So this will be alcoholic KOH and heat is given. So you are having a, if say suppose we are getting that from this carbon atom it is coming out beta hydrogen. So this will be the product butene, and if from another one then CH3, CH2, CH, CH2. That is your but1e. So it will be what? 81% and this will be 19%. Means because of the stability, it will be a major product and it will be a minor product. The third reaction or chemical property is what? Reaction with metals. In the case of reaction with metals, we have first reaction with magnesium. Rx plus Mg, we use a dry ether Over here, the role of dry ether is what? That dry ether we are using so that it can absorb the moisture and our reaction do not become a violent. So your Grignard reagent is going to form. Second reaction is with the sodium. This with sodium is a named reaction, that is your Woods reaction. So Woods reaction, what is it? We take a two molecules of the alkyl halide, two molecules of the sodium. So what happens in this case? These halide are going to attach with the sodium metal. What happens over here? Get a alkane plus 2 molecule of sodium halide. Then another one we are having a, that is your, like if we want to prepare a haloarenes, this finishes our haloalkanes. Okay, but when we talk about the haloarenes, then in the case of the haloarenes, what is going to happen? First preparation method is by direct halogenation of benzene. That is, you have taken a benzene ring, Fe or FeX3 in a dark condition, your haloarene is formed. Another can be from diazonium salt. In the case of diazonium salt, we take a aniline. In the presence of the NaNO2 plus HCl, so what we get? We get a diazonium. And with the help of this diazonium chloride, further, what you can do? If you are going to take a Cu2, Cl2, HCl, or you are taking a Cu2, Br2, HBr. So what is going to happen? Over here, you are going to form a bromobenzene or bromobenzene. This particular reaction, either of the two, it is also under a named reaction, that is your Sand-Mears reaction. Besides this, if it reacts with the Ki, heat is given iodobenzene. If you are taking a NaBF4, then benzene. Now, if we talk about the chemical properties of the haloarenes, then haloarenes undergo a nucleophilic substitution reaction. And they undergo a nucleophilic substitution reaction. Why? Because the first reason is because of the resonating effect. Second reason is difference in hybridization. Third reason is instability of phenyl cation. And fourth reason is because of the possible repulsion. However, we say at a high temperature or a pressure, several nucleophile substitution reactions are carried out. Like if you are having a chlorobenzene, you make it react in the presence of a NaOH at a temperature of 623 Kelvin and 300 atmosphere. So what is going to happen? A phenol is going to form. This reaction again is a named reaction called as a Dawes process. If you want to substitute it with the Cn, then you require to take a CuCN and DMF. Your temperature condition will be 473 Kelvin and your product will be a benzonitrile. If you react it with the NH2, then it will be, product will be aniline. Okay. Next reaction, chemical properties. If you are going to react with the metals, now over here I have taken a chlorobenzene, take a 2 molecules, making it react with the sodium in the presence of the ether. So we are going to get the diphenyl. Now over here, when it was in the case of the haloalkane, it was named as a Wurtz reaction. In the case of haloarene, it is named as a Wittig reaction. Now instead of sodium, if you take a copper, then this particular reaction is known as a Ullmann reaction and your product will be same, diphenyl. Another thing, if you take this chlorobenzene only, make it react with the 2 molecules of the sodium in the presence of the CH3Cl and ether. So what is going to happen? You are going to get the toluene. Then this particular reaction will be called as a Wurtz-Wittig reaction. Then we have the another chemical property is that these haloarenes undergo a chemical reactions, or you can say reaction chemical properties may, that is your electrophilic substitution reactions of haloarene. In this case, electrophilic substitution reaction, we can have the simple chlorination, bromination, sulfonation, nitration, alkylation, and acetylation. Means for all I am taking a example of the C. Chlorination means it is going to take place in the presence of Cl2 anhydrous FeCl3. If I talk about the bromination will be Br2, sulfonation will be concentrated H2SO4, and heat titration will be what? HNO3 and H2SO4, both will be in the concentrated form. Then CH3Cl in the presence of anhydrous AlCl3, acetylation CH3COOCl in the presence of the anhydrous AlCl3. So what will be the product? Over here we will get, in all the cases we are going to get the para and dichloro product. Para and dichloro, like over here para and dichlorobenzene, para and dichlorobromine, para and dichlorosulfonic acid, then para and dichloronitrobenzene, then para and over here it will be parachlorotoluene and orthochlorotoluene, then over here parachloroacetophenone and orthochloroacetophenone. In all the cases, your para product are going to be the major product. The reason being is due to the symmetry. Now, at last, the reactions which are very important in this case, the name reaction which you require to practice are what? Sandmeyer's reaction, Finkelstein, Wurtz reaction, Wurtz-Wittig reaction, Wittig reaction, Friedel-Crafts alkylation, Jauss process reaction, and Getterman reaction. Besides this, if a distinction test comes in this case, distinction between pairs of organic compounds containing halogen, then we have a silver nitrate test. In this particular test, halide is warmed with aqueous or alcoholic KOH. Then solution is acidified with dilute HNO3 followed by addition of AgNO3 solution. If there is a presence of alkyl, benzyl and alkyl, benzyl and allyl halides, then it is going to precipitate. If there will be the aryl or vinyl halide, it is not going to give the precipitate, and there is what that precipitate formed in HNO3. So this is the recapitulation of our unit, that is your haloalkanes and haloarenes. Thank you.